Hi learners! This video lesson is our first lesson on solid geometry. Although there are many geometric solids, this video lesson will focus on solids called prisms. The rest of the geometric solids will be on separate videos. Here, you will learn how to determine the volume of prisms. Getting the cross-sections and identifying the shapes of the cross-sections obtained upon slicing through the solid is demonstrated. Comparing the shapes of the cross-sections are also shown. Strategies in analyzing and solving problems related to the topic are showcased to let you gain an understanding on how these are done so that you will be able to successfully answer geometry problems similar to this in the future. If your lesson is on solid geometry, particularly on prisms, or if you have an assignment on this topic, or if you are preparing for a test in math, or a test in geometry in particular, or you're someone who's interested in learning math, then this video is for you. The study of the three-dimensional shapes or figures is called solid geometry. A geometric solid is a portion of space which is enclosed from the rest of the space by some type of surfaces. These surfaces enclosing the solid could be squares, circles, triangles, and rectangles. As you see, geometric solids have length, width, and height. Look at these learners. Familiar, right? This box is a classic example of a rectangular prism. With that, I'm sure you can now describe what a rectangular prism is, correct? So, a rectangular prism is a three-dimensional figure with two parallel faces that are identical, called the bases, and flat lateral faces, which are rectangles. There are 4 of these lateral faces in our box here. As you notice, the rectangular prism here is sitting on its base, and it is upright. This type of rectangular prism is a right rectangular prism. Here, we will limit our discussions on these types of prisms, particularly right rectangular prisms and right triangular prisms. Again, these are the prisms that are upright when sitting on its base like this. That being said, you have to be aware that a prism is not all the time sitting on its base, as you have seen here. Thus, you should be able to identify the base correctly if needed. Now, if all the faces in a right rectangular prisms are identical squares, then we have a cube. How much space is occupied by a prism? This is answered by getting the volume of the prism. The volume is the measure of the amount of space occupied by an object in 3 dimensions. Let us look at these learners. As you see here, this flat surface has width and length only. Thus, we can only describe the amount of space it occupies by its area. As height builds up, the once just a flat surface is now gaining thickness. A 3rd dimension is being added, the height. Now, we do not only have a 2D figure, but a 3D one. This is now our solid, in particular, a right rectangular prism. This idea is where the formula for the volume of all prisms come from. Thus, the volume of a prism is B times H, where B is the area of the base of the prism and H is the height of the prism. If the prism is a rectangular prism, B is the area of the rectangular base, which is length times the width. If the prism is a triangular prism, B is the area of the triangular base. Recall that the area of the triangle is 1/2 the area of the rectangle. Thus, if the area of the rectangle is length times the width, then the area of the triangular base is 1/2 the length times the width. Did you get it, learners? Always remember this, learners. The area of the base on the formula depends on the shape of the base of the prism. You must have also noticed that the name of the prism goes with the shape of the base. If the base is a triangle, you have a triangular prism. If the base is a rectangle, you have a rectangular prism. Because a prism is three-dimensional, it has length, width, and height. Its unit of measure is in cubic unit of length, like cubic feet, cubic meters, cubic inches, and so on. Let us look at these sample problems that follow and find out how to answer them. Here's the problem. The base of the prism is a square. What type of prism is this? Option A, square prism. Option B, rectangular prism. Option C, triangular prism. Option D, perfect prism. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. What is asked in the problem, learners? You're correct. We're asked to identify the type of prism given the shape of its base. What are given? We're given a prism with a square base. Okay, learners, take note that we're only given the shape of the base. Nothing is mentioned about its lateral faces, so cube is out here. Besides, it is not in our options. At this point, we should be able to recall two things. One, that we mentioned two types of prisms earlier. And second, that squares are special type of rectangles. So, what is our answer here, learners? Is it option A, option B, option C, or option D? Okay, so you're correct. The answer is option B. Okay, we'll now move on to the second problem. Here is the problem. What is the volume of the rectangular prism having a base with length of 5 inches and width of 3 inches as shown? A figure is given. Option A, 45.0 cubic inches. Option B, 75.0 cubic inches. Option C, 112.5 cubic inches. And option D, 225.0 cubic inches. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. What is asked in the problem, learners? You are correct. We're asked to find the volume of the rectangular prism. What are given? We're given a figure of the prism having a base with length of 5 inches and width of 3 inches. The height of 15 inches is also given. Okay, so we're given here a figure. With that, we can confidently say that we have a right rectangular prism. Do you agree? Since we are to determine the volume, we have to have the formula for the volume of the rectangular prism. Here again is the formula. Since we have a rectangular prism, then B, the area of the base, is length times the width. Therefore, the volume is length times width times the height. Plugging in the values into the equation gives us multiplying 5 inches and 3 inches gives us 15 square inches. Multiplying 15 square inches and 15 inches gives us 225 cubic inches. So, what is our answer here, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option D. Thus, the volume of the rectangular prism is 225.0 cubic inches. That was easy, right? Okay, let us look at this fruit here, learners. What shape do you think will be obtained if we slice this fruit here parallel to its bottom? Okay, so you must have observed that circular surfaces are obtained. This exposed surface is the cross-section of the solid. A cross-section is a 2D surface obtained upon slicing or cutting through a 3D figure or solid. How about if we slice the fruit perpendicular to its bottom? Will the cross-section be the same as the previous one? Let's find out. There you are, learners. You have observed that the shape of the cross-section obtained depends on the orientation of the cutting or slicing made. Slicing the fruit perpendicular to its bottom gives a different cross-section from when it is sliced parallel to its bottom. Let us look at the different faces of the right rectangular prism again. At the top and bottom are its bases. Then there are its lateral rectangular faces. Remember that in this video lesson, we are only dealing with right prisms. Okay, what shape will the cross-section be if we slice this prism perpendicular to its base but parallel to a lateral side? Let's find out. Okay, so slicing a right rectangular prism perpendicular to its base but parallel to a lateral side gives rectangular cross-sections congruent to that lateral side. Did you see that, learners? What about if we slice it perpendicular to its base but not parallel to a lateral side? What shapes will the cross-sections be? Okay, let us slice it to see what the outcomes are. So, it still produces rectangular cross-sections. Are the rectangles of the same size? You're correct. The rectangles produced are of different sizes. Now, how about slicing it parallel to its base? What shapes will its cross-section be? Let's go and find out. There you are, learners. Slicing a right rectangular prism parallel to its base will give rectangle or square cross-sections that are of the same size as its base. I hope you were able to follow, learners. Okay, let us work on the sample problem. Here's the problem. Describe the cross-section of a right triangular prism sliced perpendicular to its base. Option A, rectangles of the same sizes. Option B, rectangles of different sizes. Option C, triangles of the same sizes. Option D, triangles of different sizes. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. What is asked in the problem, learners? You're correct. We're asked to describe the cross-sections of the right triangular prism when sliced perpendicular to its base. What are given? We're given a right triangular prism and that it is to be sliced perpendicular to its base. Okay, so let us have the figure of the right triangular prism. The problem states that we have to slice the prism perpendicular to its base. Okay, let's do it. There you are, learners. Slicing it perpendicular to its base gives us these cross sections. What shapes are these, learners? So, what is our answer here? Is it option A, option B, option C, or option D? Okay, so the answer is option B. Now, what do you think will be the shape of the cross-section of a right triangular prism if we slice it parallel to its base? Okay, let's do it. There you are. Triangles congruent to the base will be its cross-sections. Did you get it, learners? There you are, learners. I hope you acquired lots of learnings in today's video. Let us summarize what we have learned today. We have learned that, first, solid geometry is the study of three-dimensional shapes or figures. Second, a geometric solid is a portion of space which is enclosed from the rest of the space by two-dimensional surfaces. Third, a prism is a three-dimensional figure with two parallel faces that are identical, called the bases, and flat lateral faces, which are rectangles. Fourth, right rectangular prisms and right triangular prisms are the prisms that are upright when sitting on its base. Fifth, the formula for the volume of all prisms is B times H, where B is the area of the base of the prism and H is the height of the prism. Sixth, the unit of measure for solids is in cubic unit of length, like cubic feet, cubic meters, cubic inches, etc. Seventh, the cross-section of the solid is a 2D surface obtained upon slicing or cutting through a 3D figure. The shape of the cross-section depends on the orientation of the cutting or slicing made. Eighth, when solving a problem, you must read it and may read it several times when needed to know what you're looking for, to determine what are given, and to figure out how the given information helps find what you are looking for. Ninth, when a figure is given, make use of it and modify when needed. It is there to help you analyze and solve the problem. There you are, learners. Hope this video helps. That's it for now. If you have any questions, leave a comment below and do not forget to like, subscribe, and share this video to your peers so others will learn too. Bye.